तो किसी मैसेज डालो आलोक या किसी को वो मुखर को डालो कि सबसे को जल्दी से ज्वाइन करें। खड़गपुर तो वो कल ही होता है, 10 5 10 10 तक होते हैं सारे।
Recording in progress.
अभी रिकॉर्डिंग क्यों कर रहे हो? अभी रिकॉर्डिंग अपना रिकॉर्डिंग अभी ऑफ कर दो, नहीं तो ये सब रिकॉर्ड हो जाएगा। अपना अभी ऑफ कर दो। A very good morning to all of you. I welcome you all to the fourth day of our FDP on assistive technologies for equitable and inclusive education. We have got the privilege to hear eminent speakers who have provided immense knowledge and shared their experiences for inclusive education. We all have gained a lot of knowledge on the recent developments and the use of technology for equitable and inclusive education. Now I would like to welcome Dr. Ashutosh Tiwari. Dr. Tiwari is a prominent faculty member at the Indian Institute of Technology Kharagpur. His broad area of specialization is biomedical instrumentation, biomedical signal processing, human movement biomechanics, assistive wearable technologies, prosthesis, and orthosis. His current area of research is gait analysis and lower limb rehabilitation. He has been an eminent speaker in various seminars on wearable assistive tools for gait rehabilitation in patients with movement disabilities. Dr. Tiwari has published numerous papers in reputed international journals and conferences, contributing significantly to the field of engineering. His work continues to impact the field of biomedical instrumentation, human movement, biomechanics, assistive wearable technologies, etc. Let's all welcome Sir to today's session. His insights and experiences will definitely enrich our understanding and help all the faculty members and the participants to this FDP program. Thank you, sir.
Thank you, respected madam, for such a nice introduction. So first, I would like to introduce briefly about myself. You have already introduced. So I am Assistant Professor in Center of Excellence in Affordable Healthcare at IIT Kharagpur. And my broad area is biomedical instrumentation, as madam already pointed out, biomechanics, and design of prostheses and exoskeletons. So I think I can start my presentation and then start my lecture.
Yes, sir, so you can start.
Right. So I hope everybody is able to see my slides.
Yes, sir, we are able to see your program.
Okay. So first of all, thank you very much for the invitation. And so through this lecture, basically, I will be talking about the recent trends in assistive technologies for locomotor dysfunction. So this is the topic of today's lecture. So first, I would like to take opportunity to introduce my laboratory, which is the Laboratory of Applied Biomechanics Research at IIT Kharagpur. And I think this kind of opportunity is good for us as a researcher because it allows us to showcase our research, what we do in our lab, and also increase our visibility all around the globe. So I take this opportunity to introduce my lab. So what we do in our lab, so we try to develop a rapid, low-cost diagnosis and smart health monitoring system, low-cost therapeutics, and technological interventions for public health and prevention of disease. Particularly in my lab, the motive is to enhance the quality of life uh, for the people who has mobility dysfunctions, for example, people with any neurological disease, for example, Parkinson patient, stroke patient, and for that matter, person with trauma, for example, amputee. So we provide kind of rehabilitation to them using some assistive technologies, low-cost technologies, and intervention. And we have a very strong clinical support in our center with, for example, Dr. Shyama Prasad Mukherjee Hospital at IIT Kharagpur, which is a well-recognized hospital in West Bengal. Then we have a collaboration with Fortis Hospital in Kolkata and many other renowned clinical centers and hospitals. And these collaborations basically help us to, gear up our research activities at the center because we as an engineer, without the clinical expertise, we can't do anything about helping the people with these kind of disabilities. So we need the expertise, clinical expertise from the doctors, from the clinician. We need patient from them. We need the clinical counseling from them, and as well as when we start developing our protocol and implementing it. So before that, we need ethical clearance. So in this way, these clinical partners help us. Now, coming to my area of expertise, so I deal with control systems, instrumentation, sensors, signal processing, machine learning, and functional electrical stimulation, which is FES, which is a technique to stimulate, artificially your muscles for various rehabilitation purposes. And the target clinical population which we are currently focusing on is the lower limb amputees, then stroke patient, the patient with spinal cord injuries, and Parkinson patients. So we basically focus on these patients for their disability in walking pattern, right? Now coming to my research area, so at LABR, we do, as I told you, research with amputees, Parkinson, stroke, and SCI. In amputees, if you come, then we try to design prosthetics for them. We try to design the control for the prosthetic, biofeedback intervention, and through EEG, we try to understand the cortical signals during various walking activities and balancing, so that we can effectively decode their brain activity. And then
Hello.
the ultimate aim here is
Hello. Hello, sir. Sorry for interruption, but your slides are not moving.
not moving. Okay, so okay, so can I stop sharing it and then reshare it? Maybe it may work.
Yes, sir.
Okay. So what about now?
Yes, sir. Now it's okay.
Okay, so I was talking about my research area. So in amputees, we do like prosthetic design and development, prosthetic control, biofeedback intervention, and cortical investigation. So the cortical investigation is basically we try to decode the intention, the movement intention from the brain activity, and then ultimate aim is to drive the prosthetic using these signals. Then in Parkinson, we try to analyze their gait because in Parkinson you will find there is a deficiency in the brain because of death of the neuronal cell, and because of that there's a deficiency in dopamine, and because of that means I will not go much detail into the neurophysiology of it because I am a biomechanical engineer. So there is a death in the brain. Because of that, there is a symptoms which get reflected in the body, and that symptom could be not motor and non-motor. So we deal with the motor symptom in Parkinson, and motor symptom could be freezing of gait, tremors, slowness of the movement, or balance-related dysfunctions. So we try to analyze their gait. We try to develop some wearable algorithms and wearable systems to, you know, help these people to negotiate their freezing of gait, or for that matter any tremors or any motor related activity, and then do gait rehabilitation. Coming to the stroke, so with stroke, we do fatigue analysis, prediction algorithm, and FES-based rehabilitation. So we, for example, in stroke, there is a paralysis, and then your muscles is not working. So we artificially actuate those muscles using FES. So that is one kind of a rehabilitation we do in stroke. And then SCI, again, we do FES kind of intervention, then IoT-based analysis. So these are my broad research area. Now coming to very important question, why treating movement disability is important. So in the next few slides, I will be talking about my research, that is development of assistive device training and other tools. And I would like to request you all, if you have any question in between, I would be happy to answer it. And of course, I can take the question at the last of presenting. So, coming to the very important question, why treating movement disability is important. So, if you see the statistics, then there are approximately 1.3 billion people, which is 16% of the world population, which experience any kind of significant disability. And this is according to the WHO. And in US itself, 27% people have some kind of a disability, and movement-related disability is the second highest. And mobility affect not only the elderly, not only the child, or not only the young people, it affect all the age people. And mostly the movement related disability is due to the neurological disorder or due to the trauma, for example amputation. And the consequences of these movement disability is decreased walking efficiency, increased risk of fall, reduced walking speed, asymmetric joint loading, and poor quality of life. And basically, if you have a movement disability, you become dependent on the family member, and then your whole quality of life get decreased. So therefore, it is very important to treat such kind of a people who have these movement disabilities. Now, if you come to the treatment intervention, that is the rehabilitation for such kind of people, then
Hello?
you can.
Sir, again, slides are not changing.
Okay.
You're on research area slide.
Oh, really? Actually, I have moved two more slides, but okay. So, is it from the problem from my side, or?
I think, sir, it's from your side only.
Okay. So maybe what I can do is, maybe I can reproject my slide. As far as I can see, I have a good internet connection here, but I don't know why my slide is getting freeze. So I'm representing it. So what about now?
It's again on the same slide, sir. It would be better if you made it on slideshow mode. I think after that it
No,
will
I'm
work.
on the slideshow mode actually.
But it is not showing. It is showing like a simple PPT.
Okay. Uh, what about now? If I'm in the slideshow mode.
No, sir. No, nothing has changed.
Okay. So means what I can do is, means I can create a PDF out of it and then project a PDF. That's what I can do. Means if it is not visible.
I think that will be better.
Okay. So are you able to see the slides means now? Means not in the
Yes, sir.
presentation mode, but in the normal mode.
Yes, in normal mode.
So can I use this format to, give my lecture if it is
So
fine with you?
just change. Now it's working, sir. Now it's working.
Okay, now it's working. Okay. So basically, I was talking about why treatment mobility is important. So I gave statistics, and then we concluded that okay, there are a lot of population who are dealing with these neurological or lower limb amputation related walking disabilities. So therefore, it is very important to treat such kind of people. Now, if you come to the solution, then we have a rehabilitation solution which can be divided into two different categories. One is the conventional rehabilitation method, the other is technology driven rehabilitation method. If you look into the conventional rehabilitation method, then these rehabilitation methods are such where you go to the clinic and there will be some clinician who will be teaching you how to walk. So they observe your pattern of walking and then they calculate something out of your pattern and then they verbally teach you how to walk within that environment. So this kind of a method of rehabilitation is very monotonous. And sometimes what happens, people uh, uh, go away frequently go away from this method, and they try to fly away from this method because of the poor engagement and lack of interest. And this method also requires one-on-one supervision and commitment from the healthcare professional, which is not always possible. So this conventional method is not very good. Then we have a technology-driven rehabilitation method, where you have the technology. For example, if you want to walk on a fixed speed, then you have an instrumented treadmill. It calculates your all biomechanical parameter. It calculates your all physiological parameter, and at the same time, it has the assistive devices which assist you during the training and as well as assist you doing some kind of activity. So this is technology driven method. But you can imagine this technology driven method is again laboratory restricted. So you have to again go to the clinics, and also these methods are very expensive. And so therefore and it is expensive since it is not accessible to the common man. So therefore there is a need of developing some kind of a wearable rehabilitation method which is affordable, which can be accessed even in remote areas, and there is should not be any need of patient coming to the clinics for their training purpose or for their rehabilitation purpose, and at the same time should be clinically effective. And if we can do that, then that can be, in my opinion, will be a paradigm shift. So this is the area which I have been working for the last few years, at least 5 or 6 years. And we are constantly trying to develop some wearable technology which can be affordable, accessible, and clinically effective. So coming to the capabilities and potentials of these wearable technologies. For example, if you see at the right-hand side of the slide, then you can see a foot pressor insole, which is wearable. So you don't need a typical force platform which is there in the clinics to measure your foot pressure. You don't need such kind of a costly instrument. You just have a foot pressure insole which can be wearable, and you can go in a real life situation and collect the data. So that kind of solution we are looking for. Then, if you look, this is an instrumented shoe which measures your gait kinematics, particularly the foot kinematics. So we don't need that costly gate labs where you have cameras and you are restricted in a certain environment. You can wear the shoe and measure your foot kinematics in a real life situation. Again, you have this wearable orthosis, and then if you see at the right, then you have this gait training system, which is a haptic based gait training system, which is again wearable. So you can be trained in a outdoor real life environment. So you don't have to go to the clinic, stand on the treadmill, walk on the treadmill, and use those costly instruments. So this is the recent trends which is going on in the area of rehabilitation engineering. So what it does is, if you talk about the capabilities and potential, it reduces dependency on laboratory restricted costly instruments. It ease gait analysis and assessment during natural walking outside the laboratory setting. It makes feasible for home-based monitoring and small clinics for low resource setting, right? So there are multiple small clinics which doesn't have a fund to, buy these costly instruments. So for these clinics, we can use this. It also allows personalization of assistive devices. What I mean by personalization is, so every individual is different from every other individual. So there is inter-subject variability. So inter-subject variability, what I mean is, so every individual is different in terms of anthropometry, sex, they are different in terms of their age, they are different in terms of their dimensions, and they are different in terms of the severity of disease. So we can actually personalize these wearable device so that their performance or their effectiveness can be increased. So there is a facility of personalization of these assistive device where we cannot personalize the device which are there in the clinic because they are unique for everybody, general for everybody. So, right, and then there is a facility of telemedicine and telerehabilitation. So these are the capabilities which we can get from wearable gait rehabilitation technologies, right? So now, before we go into the technical, research component, first I would like to introduce about the basics of gait because it is very important to understand who doesn't know about gait. So just a glimpse of it. So the gait is a clinical name of a walking pattern of a human being, how human being basically walks. So we give the clinical name to that walking pattern as gait. So we have a gait cycle, which is from one heel strike to one heel strike. When you strike a heel of a single leg, and then again you strike the heel of that leg, then that interval between that heel strike to heel strike is known as gait cycle. So you can look at the graph in the below. So the leg with the red color I'm referring to. So from the heel strike to heel strike, this is a gait cycle. And this gait cycle can be further divided into two phases, which is the stance phase and the swing phase. Stance phase consists of 60% of the gait cycle, whereas the swing phase comprises of 40% of the gait cycle, right? So in the stance phase, basically what happens, your foot is on the ground, so it touches the ground, whereas in the swing phase, your foot lifts from the ground and it is in the air. So this is how we divide the stance and the swing phase. Further, you can divide the stance phase into mid stance, the flat foot and the push off. And the swing phase can also be divided into toe off, mid swing, and the late swing. Right? So this is your heel, this is your toe. Now coming to some of the instrumentation which can be used to detect this uh, gait patterns or to analyze the gait. So as I told you, conventional method to detect your gait or the kinematics is a motion capture system, which is having some few cameras installed in a laboratory environment, and you walk, and then they track your musculoskeleton system, and then they gives you the kinematics and EMG and all those things. But that is again having a lot of problem. It's very costly. So why can't we have a wearable system? So we have developed a shoe which can measure your foot kinematics. So in this shoe, if you look closer, it has a platform where you can mount the infrared distance sensor. So if you look at the platform uh, in the front, it has two infrared sensors, which is 1 and 2, and at the back again you have two infrared sensors. And this is the bottom view of this platform. Now, when you have this arrangement on your shoe on your lateral side and you walk, then this sensors will basically calculate the ground clearance of your foot. And with that ground clearance, you can drive your foot angles, you can drive the toe clearance, heel clearance, and basically you will get to know your foot kinematics. And this is one of the component which is required for the gait assessment, or you can say analysis. So this IR sensor, I think everybody is familiar with. It basically calculates your distance. So it has a LED and the photodiode. So LED project the so this section project the LED light. And if you see this figure in the down, then for example, you have an object at B, then this LED project the light on the object B, and when it get reflected, it get incidence on the photodiode. So photodiode has these very array of photodiodes, and when the light incident on the photodiode, they generate a voltage. And according to the voltage, we can actually identify the distance of the object from the sensor. So this is how it works. Now, the main advantage of such kind of a wearable system is, as I told you, the personalization. So these system can be personalized to different foot sizes. So if you look at this frame, which is a sensor platform CAD model, so this is a stretchable frame which can be attached to different foot length. So we can use a single frame on different foot length. So it can be personalized. So cost can be reduced further, right? So this is the advantage of this kind of a frame attachment. Now coming to the working principle of this instrument issue. So as I told you, you have two sensors which basically calculates the ground distance at the back and at the front. For example, if you want to calculate the foot angle from the ground, how will you do that? So you have two rays coming to the ground. So you have distance d4 and d3, and when you plug in this distances to a formula which is the tan inverse d4 minus d3 by L, you will basically find out. So this is a very simple trigonometry. So what I'm trying to make the point is, with a simple arrangement of sensors, you can find very important information of gate pattern, which is important in gate analysis, right? And the same fashion, you can find toe clearance, which is the distance of the toe from the ground, right? And this is a real-time, demonstration of how this instrument issue works. So this is an amputee using this low limb amputee, which is a transfemoral amputee, using this shoe, uh, you know, on a treadmill, walking on a treadmill. So if you look at, so he's walking on a treadmill with his prosthesis, and you can see the data is coming. So one data is foot to ground angle, then other two data are heel clearance and the toe clearance. And you can see the graph here. So this is the toe clearance, this is heel clearance, and this is foot pitch angle or foot angle. So, right. Then there is one more variable system, which is foot pressure and sole. And this can be used for many applications in gait analysis. For example, mapping the foot profile, and which is very important in case of diabetic foot. So in diabetic foot, what happens in diabetic patient, due to the peripheral neuropathy, they end up developing the ulcer during long-term, walking. So, and the cause of that ulcer is the inefficiency, or they are not able to sense their pressure beneath their foot. So their sensation power of pressure get decreased. So can we develop something, for example, this foot pressure and so, where we can artificially tell them, okay, this is your pressure at these points, so that they can offload their foot and they can prevent their foot ulcer during the long term walking, right? So this is one kind of that kind of an instrument where you have this pressure insole, and this pressure insole has pressure sensors located anatomically on the insole surface, right? And then you have data acquisition system which is wired, so you can transmit this data to the remote computer. And for that matter, this uh, foot pressure insole can be used for feedback training. For example, if you want to train somebody for their biomechanical training, you can project, so you can calculate the center of pressure from this foot insole, and you can project that center of pressure in front of a television screen or some sort of screen, and then the user can be trained to shift their center of pressure using this visual feedback. So for this purpose also we can use this foot pressure insole. And one of such example is here, where user is being provided with a visual feedback from this insole itself, and then the visual feedback is projected on the screen. So he is trained to shift or place their center of pressure, where center of pressure in this graph is denoted by the red color. So he is instructed to place his real-time center of pressure within these two black dots. So this is how this insole can be used for the training purpose, gait training purpose, right? Then if you go to the architecture and the working principle, then I told you these are FSRs, and FSRs can be used to measure the pressure. So you have this voltage divider circuit, you plug in the FSR, you have a certain resistance, this is a voltage divider circuit, and you get voltage out of it. And then you have a calibration curve where if you have a voltage, you can basically test what is the force being applied to the pressure sensor. This is how it works. And this is the three-layer architecture of this insole, where you have a base layer, the mid layer, and the top layer. And these base layer basically form a base, and the mid and the top layer basically accommodate these sensors and the wires arrangement and all the other technicalities. Now, for example, I have showed you one video where the center of pressure feedback is being projected as a visual feedback for the gate training purpose. And this center of pressure feedback can be calculated very easily from this insole. So center of pressure is nothing but the center of, or you can say the centroid of the pressure which is acting on the plantar surface of the foot. So if you consider this as an origin, then with respect to that, if you know the coordinates of each of these sensors which are located on the foot insole surface, then you can calculate the center of pressure in the x direction and y direction using this formula, which is the weighted summation of the coordinate of these sensors with the force divided by the total force. This is how you calculate the center of pressure. So it is just a point, and so when you do heel strike, the point will be somewhere here because all your pressure is at the heel, and when you shift your foot forward, then your center of pressure will move forward, and lastly, at the end of your stance phase, it will come to the toe, right? So this is all about the research which I did for developing wearable system for the gait assessment. Now coming to very specific problem of amputation and what can be done for the amputees and what is the recent trends in the field of rehabilitation for the amputees. So first let us just introduce what is amputation. So amputation, I think everybody knows what is amputation. So it is, for example, if you talk about the lower limb amputation, then lower limb amputation is loss of lower limb from either above the knee joint or below the knee joint. So if it is above the knee joint through femur, then it is known as transfemoral amputation. And you can see in the figure, the left picture is a transfemoral amputation. And if it is below the knee joint, then it is known as transtibial amputation. What is the consequences of this amputation? Amputation obviously requires some artificial device, artificial leg to be born. But when you use these artificial leg, there is a demand of high mental energy, high fatigue, and if the artificial leg is not very efficient, then you end up developing a lot of problems over the long terms. So if you talk about the scenario of amputation in India, then in India, 20% of the disabled person encounters some kind of a mobility issues and some kind of a disability, and mobility issues is the highest among them. And it has been estimated that there are roughly 0.62 amputees in India per thousand population. And this translates to around 1 million individuals amputation in India. So amputation is a very big problem in India, particularly in if you see in army.
Hello. Sir, your voice is not coming.
हम लोग का तो म्यूट था ना हाँ
What about now?
Okay, sir. Okay.
Okay, so I missed a lot of slides, or only for this slide my voice was not coming. Could you please let me know?
Sir,
So
the
that
slide before this. and the slide.
Okay. So this slide, right?
Yeah, this one.
Yeah. So I was talking about the consequences of low volume amputation. So you have road accident, diabetes, and landmines. Landmines, basically an occurrence in the army people during the combat related injuries. So these are the consequences. And then when you talk about the consequences of for an independent, then there is a loss of mobility, loss of independence, economic, social, and psychological effects, poor quality of life, and dependence. Therefore, we need some kind of a prosthetic device which can aid in walking, right? Aid in walking, and for that matter, any other activities. So coming to the types of prosthesis. So prosthesis basically consists of, if you look at typical prosthesis, it has a socket, it has a joint, right, knee joint, and it has a foot. So it is same as the biological foot where we have a foot and the knee joint. We have a socket where we put the residual limb of the amputees, right? And then amputees basically uh, work with this prosthesis. So the problem, so the advantage of this passive prosthesis is it is low cost, highly accessible, and it can be developed indigenously, right? At least in India. But the challenges is it increases the cost of walking. So what is the cost of walking is basically the amount of energy you utilize during walking. But since this is a passive prosthesis, it doesn't have a active component. So when you walk, you utilize more energy to walk. So it increases the cost of walking. It end up developing asymmetric gait, increases the mental efforts, it increases the chronic musculoskeletal problems, and it also increases the fall, trip-related fall. Whereas when you come to the active prosthesis, which is a powered knee or powered knee plus ankle, then they have an advantage of, a high performance. They can reduce the mental and physical efforts, and they can actually decrease the metabolic cost of walking. But the disadvantage for them is high cost, and they are very complex in nature, right? So they are very less accessible. Right? So one very classic example of these prosthesis, the advanced prosthesis, which is powered prosthesis, is a transtibial prosthesis. So I would like to show you this video where the participant is walking on a treadmill with a transtibial prosthesis, where you can see it is amputated. This participant is being amputated, below the knee, and he is using this transtibial prosthesis, and this is a mechanical foot on that transtibial prosthesis. So just watch a video of this. So he is walking with this prosthesis, and this prosthesis basically being controlled. So the foot of this prosthesis is being controlled very similar to the biological foot. So if you talk about the biological foot, if you talk about the functioning of the biological foot, so first functioning of the biological foot is to support your body weight, right? So it generates a ground reaction force that supports your body weight. The other function of the biological foot is again generating a ground reaction force, but in the horizontal direction. So what is the benefit of generating a force in the horizontal direction? So if you generate a force in the horizontal direction, you can basically propel your body center of mass forward, right? So that is a basic functioning of your biological foot, that is to generate a ground reaction force, right? Now, to generate a ground reaction force in a mechanical foot, as we are generating a biological foot, we need to control this mechanical foot using some motors or using some kind of actuators, right? So, so this is an emulator system. So this is a prosthetic foot, if you can see. And so when you walk, you basically push your toes against the ground, generate a ground reaction force along the horizontal direction, and your center of mass propels forward. Now to push your toe against the ground, you need some kind of a motor arrangement. So in this arrangement, we have an off-board motor where you can see these two motors are basically on the ground, and these are connected through a cable to this prosthetic foot. And through some kind of a control strategy, we basically control this toe movement, which is very similar to the movement of your toe in the biological foot. And this is how your prosthetic foot is being controlled, right? So if you go into detail of this mechanical foot, or you can say prosthetic foot, then you have these two toes, right, which can move independently, and then you have this board and cable which goes to the motors, and this board and cable, get pulled or get released, and because of that your toes move up and down. Now, what are the challenges?
बस गोला गोला घूम रहा है नेट तो यार नेट तो बढ़िया चल रहा है
Is there any problem?
अगर आप अभी ज्वाइन मेरा ज्वाइन है
Shall I continue? Is there any problem?
No, sir, you can continue.
Okay. So what are the current challenges in these prosthetic devices? So I wanted to give you an important idea of metabolic cost. As I already told you, what is metabolic cost? Metabolic cost is the amount of energy you consume for walking, right? So when you talk about the metabolic cost of walking in a healthy individual, so suppose it is 100%, and when you talk about the metabolic cost of walking in an amputees, then it increases with 25% above the normal metabolic cost, which we as a healthy individual consume. And this increment of 25% in an amputee case, because they are using some artificial legs, so they wanted to exert more energy to walk, so they consume more energy to walk, so which is 25% more than the normal, which is equivalent to carrying a 25 kilogram of backpack on a healthy human being. So you can imagine how much effort the amputee is making to walk with their prosthetic leg. So how can you imagine? You can imagine by carrying a 25 kilogram of body weight. So this is how much the effort amputee is making. And when you talk about the elderly who have some musculoskeletal problem, they consume 60% more energy than the healthy human being, right? So particularly talking about the prosthesis, so can we reduce this, the metabolic cost? This is the challenge in developing the prosthetic and designing the prosthesis, right? So let us first understand how we can actually reduce this metabolic cost. And metabolic cost, to reduce the metabolic cost, we need to first understand the ground reaction force on our foot. So we start at heel strike, we go to the flat foot flat mid stance, and this is a area which is known as push off area, where we try to push our center of mass forward. So if we can increase the push off work from the prosthetic foot, we can actually decrease the metabolic energy which is being exerted by the amputees during walking. So we need to basically tune our prosthetic such a way that it can increase the push off work, right? So that is the key here. Now if you look at this graph, then this graph shows that as you increase your push off work from the prosthetic, then your metabolic energy decreases, right? So that is the key, right? But again, there is a challenge, because we are talking about the human being and a robot. So there is a human robot interaction, and this human robot interaction is very complex. So in human robot interaction, what happens? Human interact with the robot and robot interact with the human, right? So there are two things which is taking place, right? And this human robot interaction is dependent on the kind of the variability the human has. So if there is an inter subject variability in terms of anthropometry severity of disease, then this human robot interaction is going to be different for different person, right? So we need to maximize this human robot interaction performance for each individual, so that their performance of the device can be enhanced. So there's a challenge of this human robot interaction. So we know in general that if we increase the ankle push off work, the metabolic energy decreases, but it may not work for some people, In some people, it may be the case that if we increase the ankle push-off work, metabolic energy may not decrease because each individual is different. And that is because of human-robot interaction is taking differently in different individuals. So we need to tune this ankle push-off work so that it is customized to each individual such that it reduces the metabolic cost for each individual. So there is a role of personalization of these prostheses, right? And what I mean by personalization is human in loop personalization. So human in loop personalization is a method where you take human in the loop of this whole personalization technique. So if you see in this framework, in the image A, you have human and the robot. So there is some human robot interaction taking place, right? And you want to enhance the performance, or you want to tune this robot according to the human so that this human robot interaction can be enhanced. So how you will do about it? So what we do is we calculate some cost function, and in this case we are calculating the metabolic cost, and we are saying, okay, this is a metabolic cost and we need to decrease this metabolic cost, which is an indicator of how effective is my human robot interaction is. And we are decreasing this metabolic cost using by tuning the push-off work. So we are taking this metabolic cost in some kind of a Bayesian optimization algorithm where you have a Gaussian process where it try to match your metabolic cost with the push-off work and try to find out the best push-off work uh, which is suited for this particular individual. So it takes metabolic cost as an input, tries to tune the stiffness, or which is nothing but the push-off power of the ankle foot prosthesis, and try to give it to this. And this is an iterative process, and it goes and goes and goes, and until it find out the optimal point where the metabolic cost can be decreased. Right. So this is how human in loop personalization of the prosthesis takes place, and it is very important to increase the human robot interaction and increase the performance of the prosthesis. And this is how we follow the protocol. So in the day one protocol, what we have is known as the acclimatization day, where we try to ask the subject to walk in a different way so that they get to know how their human robot interaction is taking place, and also they get to know how their devices is working. So they basically explore the device. And in the day two, we do optimization. So we do optimization, we find out the optimal parameter, and then we validate the optimal parameter against the normal walking and against the generic parameter, right? So in the result, if you come, so we have a result from two subjects. So for the first subject, if you look at, then for the optimal push-off work, you can see the metabolic cost decreased, whereas for the generalized condition, it is at a higher value. So this is how we can personalize the uh, the push-off work for each individual and reduce their metabolic cost. Again, if we reduce the metabolic cost, also the comfort score will get increased. For optimal, the comfort score is more than the generalized condition, again for the subject, right? Now coming to very important problem in amputees, which is the trip-related falls in amputees, right? So I have talked about many problems in amputees while they are using the prosthetic foot, and such problems are asymmetric gait, low walking speed, increased energy expenditure, musculoskeletal problems. The most important problem is potential falls, and this potential falls is due to the trip related incidents. So when you have an obstacle in front of you, when you're walking with the prosthesis, you get tripped and you fall, and due to that fall there is physical injuries, increased fear of subsequent falling, and demotivation, lack of prosthesis use, social withdrawal, and it negatively impact your daily life. So it is very important to treat or to address such kind of potential fall problem in transfemoral amputees. So what I mean by trip related falls. So when you see the motion of your leg during the swing phase, then you can find out that your swing foot start with a toe off, it reaches a certain height, it goes to a minimal point which is known as the minimum toe clearance, And this is the point which is of interest to us. And this is the point when your foot comes in a very close proximity to the ground. And if this foot get arrested with the ground, you basically fall due to trip. So the possible solution to avoid this trip related fall is to enhance this, these toe clearance, minimum toe clearance. So we have come up with an hypothesis in a passive prosthesis where we say that if we change our center of pressure during the stance phase, right? So when you put your foot on the ground, you strike your heel first, and when you strike your heel, this small dot is nothing but a center of pressure. So if you shift your center of pressure by striking your heel with a different foot inclination angle, then what happens is your push-off during the late stance changes. So when you shift your center of pressure posteriorly, the push-off increases in comparison to when you shift your center of pressure anteriorly. So we asked the participant to shift their center of pressure posteriorly during heel strike so that their push-off increased. And once their push-off increases, their swing kinematics get changed. So if push-off increases, their knee angle increases, and that minimum toe clearance basically increases. This is how we formulated our hypothesis. And then we tested our hypothesis where we asked the subject to walk with this kind of a visual feedback. So we instrumented the subject with a insole and the instrumented shoe, where we calculated the toe clearance using this instrumented shoe and calculated the center of pressure using foot insole, right? And then we projected the center of pressure on a visual screen, which I have already shown you, and then asked the amputee participant to shift their center of pressure posteriorly, right? So that we can have the increase in a minimum toe clearance. And this is how we train the participant in a real life environment, where you can see the participant is walking with their prosthesis with the visual feedback, and this participant is asked to put their center of pressure within this two black dot, right? So what we found out was, if the participants shift their center of pressure posteriorly, which is denoted by this yellow color, then their whole toe trajectory shifted upwards. And if you see this star mark, which is nothing but a minimum toe clearance in this toe trajectory, then this minimum toe clearance also increased with the posterior center of pressure feedback in comparison to when we give no feedback or we give anterior center of pressure feedback. So this is a classical example where we can use some wearable device to project the feedback and train the participant effectively to enhance their walking pattern, or to improve their walking efficiency as well as walking style. Now, this is another research which is very important in terms of uh, providing rehabilitation to the athletes. So if you talk about the athletic person, they wanted to have their high performance in comparison to others. And in athletes, the high performance is all about walking at a higher speed, finishing their line quickly in comparison to other person. So for that, we need to basically increase the efficiency of these athletic uh, person, right? Or you can say decrease their metabolic cost of running, so that they can run without getting fatigue and they can win the race. So we have designed a passive hip exosuit, where you can see in the left hand side of the image. So in the passive hip exosuit, you have these elastic bands, and these elastic bands are kept across the hip joint. So they assist.
स्टेशन पर सन्यासी शपथ था सीएम योगी ने किया रेल
So
मंत्री
they
को
assist. So they assist during hip flexion or for that matter, they assist during different range of motion. And how they assist is when you walk, they store energy during one phase of the gait cycle, right? And then they release energy during another phase of the gait cycle. So when they release energy during another phase of gait cycle, they basically assist during running, right? And if you look at the image at the right hand side, and if you look at the schematic of it, then this is the line of action of force and this is the hip joint. So if force is acting at a radial distance, perpendicular radial distance of r, then there's a moment which is there at the hip joint. And this moment basically assists during running or for that matter walking. So for such kind of a device, again the problem is personalization, because some people can prefer to have these bands on the anterior side. Some people prefer to have these bands on the lateral side. Some people prefer to have these bands on the posterior side, depending on their walking biomechanics and gait kinematics. So we need to personalize these band positions according to the subject. Again, so we have something known as human in loop personalization of these band positions. So if you look at this figure, again, the cost function or the deciding factor is again a metabolic cost, because we personalize these systems based on the cost function. That is, we want the metabolic cost to get decreased. So we take metabolic cost as an input to these optimization algorithm, and we try to optimize these band positions, which you can see in the orange color over here. And these band positions across the waist. So we can optimize the band position for that particular individual based on this metabolic cost. So this is a kind of human in loop optimization of band positions, right? And this is a real life situation where the participant is walking with these bands, and so we are like getting this data within the laboratory environment, right? And coming to the results, so what we have found out, if we have an optimal position of these bands for all the participants, then we have found out then when they are not using any exosuit and when they are using the optimal, they basically decreased their metabolic cost by 6.64%, which is huge. So this kind of a result is an encouraging result which can be directly applicable to the clinical population as well as for the athletes who wanted to increase their performance during running, right? Now, so my research is basically developing the prosthetic device, developing the intervention, and also developing the training device. So one of uh, the segment of the training uh, device development is developing devices for Parkinson patient. So we try to also develop device to mitigate the freezing of gait in Parkinson patient. So what happens in Parkinson patient? So I will not go into the neurophysiology of what happens at the brain level or at the cell level, but as a biomechanical engineer, I would like to tell you in Parkinson patient, there are some death in the brain cell due to X many reasons, and because of that, there is a deficiency in the dopamine in the brain, and because of that, there is a dysfunction in the motor activities, right? So in Parkinson patient, if you look at, so you will find a lot of motor symptoms. For example, they will have tremors in their hand, and for that matter, in their lower limb as well. They will have rigidity, that is the slowness of the movement, bradykinesia, which is called as, and they have a problem with the balance, right? And one of the important class of these motor symptoms is freezing of gait. So what is freezing of gait? So in freezing of gait, uh, although the patient have an intention to walk, they get stuck to a certain position, and they feel that their foot are glued to the ground. Although they have intention to walk, they are unable to walk, and that is a typical motor symptom in freezing of gait. So we try to develop variable, intervention to mitigate this kind of a freezing of gait in Parkinson patient. So you will have a good amount of idea if you look at this video where the Parkinson patient is walking with such kind of disability. So the patient is walking normally, but it when they get a turn, they kind of stuck to the ground because of their compromised motor activity and planning, execution, and all those things, right? And it usually happens during the turns, and it usually happens when there are narrow pathways and obstacle during the pathways. So this is the problem with the Parkinson patients, right? So now how to solve this kind of a problem? So we have come up with a training system, which is a haptic biofeedback training system for Parkinson patient. So we try to, provide some kind of a haptic biofeedback to these patients. So if you talk about the treatment, traditional treatment, or the conventional treatment for this freezing of gait, then you will find that there is some technique known as deep brain stimulation, DBS, where they try to stimulate your damaged cell using some external electrical impulses on the brain. So that is very costly and not very practical solution, although it is very effective. Then other solution for treating this freezing of gait is using medication. And so there is one popular medication which is known as levodopa, and this medication is very effective in treating the motor symptoms as well as the freezing of gait. But again, this medication has some duration of effect. For example, if you take now, its effect can last for next 5 or 6 hours, and after that you need to take again. So you have to depend on the medication. Also, if you keep on taking this medication for the longer term, then the sensitivity or the effectiveness of this medication get reduced. And also there are a lot of side effects of this medication. So we have come up with some kind of a technique, training technique, which can be training technology, which can be wearable and can instruct the subject to walk and then mitigate the freezing of gait, right? So in Parkinson patient, one of the problem is they don't get sense of their movement. For example, if you talk about the ankle movement, there is a lack of ankle range of motion proprioception. Proprioception is the sense of their ankle range of motion. So what we did is we tried to provide them the sense of their ankle range of motion using this haptic biofeedback system, where if you look at the right hand side image, we basically provide the haptic feedback when their ankle angle or the foot angle is greater than certain threshold. So if it goes to above a certain threshold, then we provide a haptic feedback, and if it is below the certain threshold, we don't provide, so that they get a sense, okay, uh, I'm making an angle which is greater than certain angle. So this is kind of a biofeedback of their ankle range of motion we are providing through the haptic modalities. So for that we used obviously the developed foot uh, shoe, which is, I already spoke about this. So it basically gives you the foot angle, and then we use these tactors, if you can see, to provide the haptic feedback. So now the subject will be asked to walk, as you have seen in the video, of almost 7 meters of walkway, take a turn, and then come here back, and then again take a turn. So you will go round and round for certain cycles. So this is what the protocol we follow, and we have recruited 8 subjects, and we have measured uh, mattress, which is
मेरे फोन
time
की
spent
प्रॉब्लम थी
fixing,
मैंने जब
with
इसको फोन को
RFT,
वो किया
which is
बंद करके
defined as the
चला
sum of duration of FOG
तो 2 साल हुए
divided
मेरे
by
साथ
the total time of walking. So we can plot this RFT against, no Q. You can see, so off means medication off with no Q, and off C means medication off with Q. So with Q, you can see the freezing of gait get decreases. So this is the benefit of such kind of a device, where we can mitigate the freezing of gait. And this is a real life video where you can see we have not provided the medication in either of the cases, in both the cases. But on the left hand side, this is with Q and without Q, and this is with Q. And you can see the difference clearly here. So first, let us see this. So this is without Q. We are not providing any kind of haptic Q. And Parkinson patient is walking without medication. So without medication, obviously he will freeze. So you can see he is freezing during the turns. So this is very debilitating problem with the Parkinson patient. And due to this, they consume a lot of energy during walking, and their walking become inefficient. So this is the case without Q. When we switch on our device and then ask the patient to walk, you can see he is making a certain angle because the device is telling him to make a certain foot angle. You can observe that. And then he basically mitigate or negotiate that turn without freezing there. So this is the advantage of such kind of a training device which can be developed. So you can see there is no freezing, and he smoothly negotiate the turn. Right. So this is the advantage of such kind of a device development. So I think I'm done with my presentation. And so if among the audience, if you have any question related to any of my slides, I would be happy to answer those.
Hello. Hello. Thank you, sir, for such a nice presentation. Sir, I have one or two questions. Like you
Right.
told this in Parkinson patient, there is a dysfunction in the motor function of brain.
Right.
So, and you also told this gait function is related to this motor function. So, sir, can you clarify how this gait function is related to motor function of brain?
Right. So gait is a walking pattern, right? To walk, you need to move your limbs, right? You need to make some certain angles at your knee joint, at your ankle joint, at your hip joint, right? Now, to make those angles so that you can walk, those angles can only be actuated by motor signals. So let me explain you from very basic. So if you consider your human body as a black box, right? You don't know what is inside the black box. So what you know is you know the input to that black box, which is the motor activity which is coming from the brain, right? And at the output, you are able to see the movement of your limb. But in between, you don't know anything, right? That's what your layman can understand. But if one has to understand what goes inside, then once the motor signal originates from the brain, it goes through the nervous system, it goes to the muscles, and muscles get actuated. What I mean by actuation of the muscle get
Hello. 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 Sir, your voice is not coming. Hello.
and relax.
Hello, sir, I'm not able to hear you. Hello. You're not audible.
and due to which, since the muscle is attached, so this motor activity or the motor signal is responsible for making an angle. And
So,
Hello, sir,
yeah,
am I
so
audible?
yeah, you are audible. You can ask the question.
Sir, so in training section, you have also told that biofeedback kind of training you have provided for this for Parkinson patients. So
Right.
can you told two or three what kind of feedbacks you have provided? You have
So
to.
the right. So biofeedback, what we have provided is the haptic biofeedback. Right. So haptic means the vibration. So we provided the vibration to the participants. So see, biofeedback is providing some kind of a information to the participants about their physiological information or about their biomechanical information. So what we did was, in the Parkinson case, we calculated the foot to ground angle, and we wanted the foot to ground angle to be understood by the participants. Since they have a problem or deficiency in understanding the range of motion of the ankle, so we are making them understand using some artificial means. So we calculated the foot to ground angle, and then based on that foot to ground angle, we actually put some kind of a haptic motor, or you can say vibratory motor, on their skin, right? So in skin you have a mechanoreceptor which basically get activated when there is a vibration, and you will get to know that there is a vibration. So we map the foot to ground angle with that vibration. So if the foot to ground angle, let us say, is 0, the vibration will not be there. So we have an algorithm in between which decides whether to give the foot to vibration or not. So if the foot to ground angle is 0, we don't give vibration, and if the foot to ground angle is above a certain threshold, we give a vibration, through these tactors. And through this vibration, Parkinson patient get to know, okay, I'm making this foot to ground angle, and this information of foot to ground angle, which they are not getting biologically because of the deficiency in their proprioception, which is a kind of a biofeedback. So if they get this artificial information, they basically try to negotiate their freezing of gate, right? So to answer your question in a very short point, we are using the vibratory motor to provide this biofeedback to the participants.
So like you have shown us for the lower limbs things. So same
Right.
for the upper limbs. If a person is shivering with their in their hand, so can we use this kind of feedback in that case?
Yeah, we can use this kind of a feedback, but you need to know what kind of a feedback you want to deliver. So there are two things. One is the modality of the feedback, right? And the other thing is what is the information you are trying to deliver. So here the information is foot to ground angle, and the modality is vibration. So you are giving information of FGA, that is foot to ground angle, through vibration. But as you talked about the upper limb, then first you have to know what information you want to deliver. So that is first component, and that information you can deliver using vibration or using visual feedback or other modalities. But the important thing is you need to do a literature survey. You need to know the science behind it, what sort of information you want to deliver it, right? So the information is different from the mode of delivery. Mode of delivery can be anything. It could be vibration, it could be auditory, it could be electrotactile, it could be visual, it could be other many kind of modalities, right?
And
So I
sir,
hope I'm clear.
yes, sir. Sir, one more question. Like
Right.
you showed us your instrumented shoes with that show sole, and you also show us the exoskeleton for lower limbs prosthetic. So, sir, how it is different from that Jaipur boots which are mostly people are using? So, have you implemented some new parts in that boot, or it is similar like that, or
Okay,
some
so you are
additional function you have added?
right. Right. So you're talking about the foot which I showed you during the video. The participant is walking on a treadmill, right?
Yes, yes, yes.
Yeah, so Jaipur foot is a sach foot, right? Solid ankle, cushion heel foot, right? So it doesn't have any kind of a active component in it. For example, if amputee wear a Jaipur foot, then they cannot do any kind of range of motion at their ankle joint. So it is very rigid foot, right? But if you look at the biological ankle joint during walking, then that biological ankle joint has got lot of function to do. It basically, as I explained you, it supports your body weight. It helps you propel forward. It basically, resists you to move forward. So there are different things which is contributed by this biological foot, and that is contributed because the ankle is moving. There is an ankle range of motion. So if you consider the Jaipur foot, there is no ankle range of motion. So you cannot have those biological foot functionality. So what I developed was the active foot, which mimics the biological foot, which can have the property of the functioning of the biological foot, so that your walking pattern can be as natural as your biological walking pattern, right? So
So,
in
sir,
that
have you,
in that
have you,
active foot, right? Please.
sir, have you commercialized this food?
No, we have not yet commercialized. We are still in the development stage and we are still in the R&D stage of it. So
So,
we are
sir, the
looking at different aspect of it. Right.
last question. This is the problem of this biomedical instrumentation part. We always, whenever we are working on any kind of prosthetic things and that cytoskeleton, yeah, SOX, the main problem is we need to provide training to
Right.
each individual. So how can we reduce this training thing? Can any other method? We can not like if a person is getting 5 or 10 days training, can we reduce that in 1 or 2 hours? We can provide them a training for that instrument. So
Right.
how can we work on that area?
Right, right. So I think it's a very, very important question when we talk about rehabilitation, and not only the lower limb rehabilitation, for any kind of rehabilitation, training is very important. For example, as you already pointed out, for example, however the advance of our prosthesis is, if you don't train the subject to walk with the prosthesis, the performance of that prosthesis cannot be taken into account. So training is very important first of all. Now, you're talking about how can we reduce the time of training, and at the same time, the important question is how can we make it effective. So effectiveness as well as reducing the training time, so that there is a quick recovery, because recovery time is also important. Because if you ask the subject to come to the clinic for 10 days, it's not very viable situation. But if you rather ask them to just come for 1 day for 2 hours, and you will be done with your training with a high efficiency, then it's a great thing. So how can we reduce it? So the first thing is we can include technology based rehabilitation. So as I already told you, we have a conventional rehabilitation where we use different conventional techniques like watching the walking pattern with a naked eyes, and then instructor verbally instructing the subject to walk. So we have to come out of that conventional matter and we have to go towards the technology based interventions. And so what I have shown you through the slide is mostly the technology based training intervention. And so there are various techniques. For example, if you want to make the training quicker, then you have to explore these technologies. For example, if you want to train lower limb uh, training, then there are different techniques which are available. For example, EMG is one of the technique for rehabilitation, then biomechanical sensing, and then there are different modalities. So my point is, we have to go towards technology-based intervention, we have to go towards technology-based rehabilitation solution, and then we have to explore different technologies which basically suits our purpose. And I have to add one more thing here is the personalization, which is a recent trend in rehabilitation, because when you train the individual with a very generic method, although it is technological, he or she may not be able to recover quickly because that methods may not suit his or her,
Correct.
body or walking plus its personalization will make the recovery quicker and reduce the training time.
Thank you so much, sir.
Right.
नहीं वो निकला ला इनको आपको
So, are there any other questions? Yes.
Thank you, sir, taking the time out of your busy schedule to be here. Sir, please can you share your PPT on the mail?
Sure, I can share. I will be happy to share it.
Okay. Thank you, sir.
So, I guess we are done with the question and answer session, right? So, is there anything else like because I have a meeting at 11:45, so I need to leave. So if there is anything, I can engage myself for another 10 to 15 minutes. Please let me know.
ये फोन आया था मीटिंग में यार इसलिए फोन आया एफडीपी की मीटिंग
Sir, I think there is no one who would like to ask a question. Sir, so can you
Okay.
make?
Okay. Thank you very
Thank you,
much.
sir.
Thank you.
Good morning, everyone. Now, our next guest speaker is Nidhi ma'am, a renowned entrepreneur, founder, and CEO of Nema AI. She completed her studies from Delhi Technological University in electrical, electronics, and communication engineering. With a background in neuroscience and AI, she specialized in developing AI. Her passion is about merging neuroscience with artificial intelligence to create innovative solutions for education and marketing. She also appeared on Shark Tank season 3 with her startup Nema AI. Now, I would like to invite Ms. Nidhi ma'am to share her views on topic the role of assistive technology in education.
Hi, everybody. Thank you for the introduction, team. So, today we're going to talk about the role of assistive technology in education, and we will also talk about Shark Tank if you guys stay active during the presentation. Let me share my screen. Please let me know once it's visible to all of you.
Yes, ma'am, it's visible.
All right. So, welcome to the webinar on the importance of assistive technology in education, everybody. So, first of all, the topics which we will cover is what exactly is assistive technology, what are the types of assistive technology, benefits about it, should we have a data privacy, quality standards or not, and how Nema AI is actually working towards an assistive technology and providing that support and social impact. So before I start, anybody in this conversation know about assistive technology already? Can speak up and just say yes or no, and then I'll take it forward as well.
Yes, ma'am.
All right. So assistive technologies Assistive in general, the word basically means anything which can assist any individual or a group of people. Now, if you go by the Individual with Disability Education Act, assistive means anything which can increase, maintain, or improve your ability to be functional, either when you are traveling from one place to another, which is what the wheelchairs are for a lot of disabled individuals out there, either when you are trying to have a conversation, when there is a dumb and deaf kind of individual, they would need a speech to text or a chat box for communicating themselves. So now overall, these assistive technologies have actually changed the innovation of their technology as well. If you see the phone, right, which we are using right now, was actually meant for the people who couldn't communicate using their voice, so that they can type and then tell the person right in front of them that I need this kind of thing, and that actually revolutionized the entire the phone chatting and etc., and then changed the letter writing to this innovation of having a phone in every individual's hand. So assistive technology might seem a very new word, but it has been there for a very long time. Now, if I talk about the types of assistive technology, if you're aware about individuals who have intellectual or developmental disabilities like autistic, ADHD, Down syndrome, cerebral palsy, or you might have observed that some student in your school might have fits. Now, all of these are some kind of intellectual or developmental disabilities or conditions, I would say, not the word disability, which happens either because of different parts of the brain when they were getting born being like made in certain manner that the abilities has changed. Now for these students specifically, the assistive technology could be as simple as a pencil and pen grip kind of a support, because their motors doesn't work. When I say motor, it is about the muscular ability of a hand to hold a pencil and pen. Now for some individual, their vision is not really there that much since they are born. It can be partial vision also. So for them, this text might or might not be useful. They would need everything in a very large print and with colors also. Then adaptive pencil. For some individual, the pencils has to change the shape because their hands has been born in a manner that they can't hold the pencil which we are holding. Audiobooks. For some individual, for them to actually read the entire thing is not possible because of fully vision is not there. Then they would need that podcast kind of scenario where they can listen to everything while they are going through it. And these might have like podcast, like you have already podcast is right now in trend also. So if you see, these podcasts are actually serving a great amount of assistive technology for individuals who want to learn, but at the same time want to gather the new information which is going on. So audiobooks or podcasts are one example of these kind of assistive technologies. Secondly, it is tape recorders. Now, if you've seen the movie Shrikant, which just came on Netflix, that movie had one of the individual who had no vision. Now, that individual, the teacher who was actually trying to teach him, made that tape recorders for the entire book, and that that individual who was given that opportunity to at least have these tape recorders create a full channel of a lot of individuals with no vision to have that education at least till 12th, and as of today even for college standards and etc. Now there is word processor also. You might have heard about the system talking to you when you are trying to click. So you might have 1 second, I'll just get back, sorry for the disturbance. Yes. Yeah, so we were talking about the student Shrikant who was in the Netflix movie as well, where he was given that opportunity to go through the entire subjects of our syllabus from a tape recorder format rather than the book which is out there. Now, there is Braille obviously, but at the same time, Braille's when it comes to a 11th, 12th standard student might not be that effective because how much can you present it in a format which they can understand? So, simple innovations like this can change a life like for millions out there. Now, if I talk about high tech, AI based assistive technologies, which is what Nema is also doing, and we'll get back to that as well. So, there is speech to text. I'm not sure how many of you have used the WhatsApp feature of mic, where you can speak and then it types for you everything whatever you want to say. So that simple application now your mother also use who doesn't know how to type properly if they are not that educated. So that helps both the visually impaired, the both the with motor or I would say mobility issues, and at the same time it creates the like it bridges the gap between the educated and non-educated individuals as well. So a simple speech to text created for the visually impaired but is helping both the neurotypicals also. Now, screen readers. I just mentioned that there is an accessibility system in all our systems, even in phone, even in laptop, where if you say, can you please read it for me? It will read the entire message to you instead of you reading it. Alternate input devices. I'm not sure how many of you know, but there are touch screen based system, modified keyboard, like the one which we have is a simple straightforward one. But for some individual to use their hand or move it around, this kind of keyboard is very difficult. So the keyboard itself is in a C shape, shape, which is very different than the way we use it. It is obviously expensive and the accessibility of those is very low, which creates a lot of barrier also for individuals to access it. But the invention at least helped multiple students out there. OCR is one of them, which is actually similar to speech to text. OCR reads text in an image now. Now, let's say if you have a full book, you can't have a teacher who will be recording your entire thing in a tape recorder. So, AI has helped that part also, that you give me the image of the books which is there, and I will convert it into a text format, which again you can do to text to speech. So, it's a full image to text to speech. Three kinds of AI getting involved together, and then reducing the manual work which is required to provide this kind of assistiveness to an individual. Talking calculator, I think that is similar to the screen recorders as well. And microphones is obviously the student with hearing impairments, they have to either wear it, or there are, I would say, the implants which also happens for students, so that they can, whoever can hear partially can at least hear it inside as well. Uh, is anybody aware about the AAC, which is the augmented communication devices out here? Have anybody used it also? All right, I think I consider the silence as no, you're hearing the word also for the first time. So AAC basically means anybody who cannot communicate or has a challenge of expressing or about like expressing their ideas or feelings would need a technology who can communicate for them. Or for some individual they don't even need a technology, they can just do the same by gestures, which you also as an individual might be doing it. Let's say if you want pen in your class and you're sitting at the front seat and your friend is sitting actually two or three seats behind you, so you will do an expression rather than shouting. If there's a teacher in the class that, hey, I need a pen, can you give me? And that expression itself is one part of AAC. Technology based AACs also are there available, which we will talk about. But simple AAC would be facial expression. When I can't speak using my voice, like how I'm doing it right now, how else can I communicate what I need? It would be gesture, facial recognition, happy, sad, or pointing towards letter that A, B, C, and then someone will be tracing it back like a puzzle solve, or presenting photos or pictures in front of them and they'll be showing it to you from the internet itself that, oh, this is a dog, can we go take my dog for a walk? That simple sentence framing and etc does take time, and it's almost like playing damsharas with your friend. But for some individuals that's the way of living as well. Now if I talk about the first, I'll talk about the tech based AAC. So now you might have heard of tab. Avaz is one of the startup who is working on AAC, which is a tab-based system where individuals actually have their A, B, C, D also on the screen, which you can click and then it speaks for you, or all the photos, which again it can speaks for you. So it's basically whatever we have been talking about, all the facial expression, gestures, etc. Instead of having an assumption that I want that or this, the screen has it that Nidhi wants to speak right now, or Nidhi wants a water of glass. That four buttons, when clicked, create a sentence instead of the student writing it all together because they don't have motor in itself as well. I'll talk about the benefits also of the assistive technology. Now, what we don't realize is that when a student who's going to school has no way of communicating what they need and what they're not able to understand, that creates a lack in their social self confidence, social skill, independence, and even empowerment in a lot of cases, because they feel so I would say conscious that I can't do this, maybe I am dumb, even though the problem is that at school the right support which the student required, either in terms of an assistive technology or in terms of counseling, was not provided to him or her. So they back off from any new opportunities and then just go with the flow, and sometimes are not even traced or helped back. If you give them the way to communicate through these assistive technology, like for example, you can provide them computer technologies with laptops, processors, or I would say devices which they can use to study. Like right now, I'm using a laptop to present whatever I want to express to you. So this is also one part of assistive technology where, if let's say I didn't know how to type, I could have just made this PPT and asked my system to present it for you, and then in between took your feedbacks and again type the answers and then again speaks for me. Now, kids who have autism, ADHD, or these intellectual differently abled students, right? They do not know how to utilize communications also, and they have, in a lot of scenarios, sensory overload. So for them, the kind of support which they required is that noise cancellation headphones or awareness within the school itself across our neurotypical students, that students who have neurodiversity might be a little more sensitive towards light, sound, noise. So instead of laughing, bullying them, have a conversation with them and provide them that support, that it's okay, take a breath, or at least ask their counselors to reach out to them before it's too late and the student gets too high. Now, students who have learning disabilities. Now, these students actually, the disability word in itself is a problem these days. So, students who have learning conditions also, they might not have any problem in terms of communicating, in terms of using pen, pencil, or laptop, but they would have a cognitive challenge of understanding the same topic. Now, it doesn't, like when I say cognitive challenge, that doesn't mean that they don't know, they don't have the capacity to learn, but actually they don't know how to use their own ability to study that same topic. So that's where Nema I also support, and we'll be talking about it as well. So for students who have visual impairments, language hindrance, for these students specifically, when you give them a technology which can speak for them, type for them, or even create like through Gen AI these days, the entire creatives for them, that gives them that independence. That okay, now instead of me writing everything, which takes a lot more time, I can just express myself using these AI, which provides that aid for the students, that aid for me to communicate and learn faster and provide outcome faster, and maybe have a job also in future. Now, I've talked about the benefits already. Now, let's talk about why is it so important that we all together out there create that mandate that we should have assistive technology in our institution, in our home, in our school, or wherever we are going. So you have seen, I think, that wheelchair pathways which are coming up across airports, school, colleges. It's a mandate now that you need to have stairs and you need to have the uh, slope, basically. I'm not sure what the word would be for the students who have wheelchair again. That's again one of the assistiveness or providing that accessibility to the college infrastructure itself. So these simple steps can provide a path towards equal opportunity for a student to learn and work on their overall education as well. If you see, the 80 in education system actually began very late, like somewhere around 2009 and 20. The conversation started, and 2017 is when it actually came in the school and in the education system. And with that, the first one was US, then Brazil, Turkey, and in India, it even started very late. So we are at 2024 today. So if you see, 2024 is when we are all sitting together and talking about the importance of assistive technology, the importance of highlighting that the conditions which one is born with should not be the barrier in their education or in actually absorbing what is being provided, so that they can have that knowledge which they are looking forward to. So it's very important for all of us to talk about it in a more awareness and knowledge perspective rather than taking it as if a burden on us. Because when there is someone who is disabled and they are not able to get the education, it is the education system which is wrong, not the individual with disability who has it, because he was born with it. But the education system has been created by us. So when we who are not with disability are not giving access to these individuals, that creates gap in overall providing that equality of education and the right to at least have the knowledge of what they want to learn and how to progress as well. Uh, when you positively, the positives of this assistive technology in education is academic engagement of students with disability or intellectual abilities increases, their social skills increases. The individual who is the only child of a family has now a hope that I can also earn for my family one day after learning, because my college or school or corporate has that technology or has that support for me, so that I can actually access the infrastructure, the education system, and then maybe the employability also. So it creates a lot of academic performance, motivation, and attention also for these individuals who have different kind of abilities as well. Now I'll talk about Nema AI. So at Nema AI, what we do is we have created a very smart edtech platform, but we use EEG, which is the brain patterns of an individual, and artificial intelligence. So we are a neuroscience and AI based startup where what we do is you wear a EEG headset. If you have not seen Shark Tank, our episode as of today, you can check. We just recently came on the season 3 itself, where we did this scan, the EEG scan for Anupam as well, where you wear a EEG headset. I'll show how it looks like as well. Once you wear it, you play some games. Nobody's asking any questions. We'll have a full brain mapping of you, how you well you do you learn, what are your gaps in terms of are you not able to memorize the same concept, or is it that the thinking or association between two concepts is very difficult for you. So if these answers, once we have identified you, both for the individual with neurotypical or neurodiversity or any intellectual disability, it's a very inclusive product. So we say inclusive because the solution can be used in a market where you don't have either motor abilities, visual abilities, or intellectual abilities, or even if you have all of these, and still you feel that I'm trying my best to learn the topic, but somehow when the teacher teaches me at school, I'm not able to get it, and you feel that I am dumb. Though the reality is the way someone approached you when they were teaching you was different than the way you learn it. So that gap of identifying why is the student not able to learn is what Nema AI does. And that is done through the brain patterns, which we are able to capture through the EEG of you, and then provide you a customized program on personalized level that how you can improve yourself further. So the benefits of this particular solution which we have Nema is for the teachers is that now teachers doesn't have to fixate on the idea of how do I create that personal approach for the student. When I'm talking about, now this is specifically I'm talking about students who have intellectual disabilities in a school, which is certified by RCI, which is Rehabilitation Council of India. So over there, the teachers actually create these individual education plans manually. They sit together with the student, understand them for 2-3 months, then take 1 or 2 months to make that content, then teach them. So there's a proper lag of 6 to 7 months. By the time the teacher understood and actually started teaching the student, it already went from like 6-7 months already went into vain. Now, Nema is actually crossing that entire 6 months and giving you insights to the teacher that, okay, these are the problems, gaps in their learning, and these are the strategies we are providing you so that you can at least take them forward and teach your student even better. It has helped the teacher become more flexible rather than working on the manual work, manual task of creating contents. Now the teachers are able to at least focus on effectively providing that solution using the digital aid we provide, where the platform talks, speak, and in some cases you can type as well if you don't know how to speak or if you don't know how to express yourself. Secondly, the teachers now has more students to work on rather than the same teacher working on one student or two students and then creating their IPs. So it has increased the efficiency of the teacher also to provide the solution right. Third, because it's digital. So let's say today this teacher has shifted to another state because of any family reason. That won't hamper the student's ability to learn, because the new teacher will come and she will know that these are the things the teacher has covered and this is where we are. And now we can move forward and then help the student to become better and age specific class as well. Specifically for students who are autistic, ADHD, Down syndrome, I'm talking about. To the student, it has created personalized learning experience. Now, when you know me, if I have autism and if I'm not able to express myself, that when you're trying to teach me, I'm not able to learn, that creates a gap in their overall learning and education, I would say. But through this experience of Nema AI, the student without even speaking has been benefited, because now we know that this student specifically would need audio based intervention instead of someone just writing on the blackboard or showing them flashcard, this is an apple. So instead of that, when we improvise the content which was given to that student to learn, it helped him actually learn and then obviously improve as well in academics as well. uh, we have already helped multiple students out there in hundreds, I would say numbers, who have now moved towards, now these are adult autistic and ADHD students who would not move towards education anymore, and they would be moving towards employability, internships. How can we earn? Because even they don't express, it's still very visible that they also want to do something, not just go through education system like a case study. Why I'm saying case study? Because when you meet any individual who has disability with respect to physical disability, right, like a wheelchair or a motor function, their cognition is still there, so they can tell you that this is not right, I need support. And then once they raise their voice, that support is given to them. It's delayed, but it has started. But for students who have these intellectual abilities, they do not even know how to express that feeling, that whatever you are telling me, I am not able to understand. So that gap now has been filled, and now they are moving towards internships also. Now, as we move forward, even when I'm working on Nema AI, we take care of data privacy at the highest level, because this entire domain has been so untouched. Any data which you collect today would be very new, and any data which you have storing today can create a problem for the individual whose data it was. So if you don't follow the GDPR, which is the global data protection right for any individual, it might create a problem for your application if you're a student as of today who is in the webinar, or it can create a problem for a company, because you can get sued because you have leaked the data by mistake or you have not masked them properly. And now the individual who actually came to you for a scan or for any accessibility of the solution are not really able to feel confident, but they feel threatened that everybody knows about that this is my condition and these are where I'm lacking. So data privacy is very important. So you should understand some simple steps is always you have unique IDs for your user. If you're making any application as of today, always follow the cyber security, data security methods. AWS has all of it already. You can read about them, you can use their automated ways, or you can create your own. Then the data retention part, have a cycle around it. Once you feel that the data which you have is not required after a certain point, discard it or keep it masked only for research. But never, like it should never be actually accessible to any individual out there or even to you, that you can go back and say this person in ID is matching with their current data. Lastly, when we talk about the data sharing and disclosure, right? You should never disclose anybody's data, because that can create a lot of problem in having that next customer. Always take consent, I would say, before you go for any kind of pilot research or even a product trial or product delivery out there. Then full rights to personal data. So let's say if the user will not want you to store. So once you have gathered the information, once you have given them that this is the solution, if they say, please delete my data, that means you will have to delete it. Even for R&D purpose, you can't keep it. So these specific norms, when you keep in your documentation while you're taking consent, while you are making any application, can help you and the individual who's coming to you trust and validate your own solutions a little more as well. Now, this is almost the end of the PPT, and the message would be that if you have read about David Barclay, that any class should have, I would say, technology in every classroom for every student and even for the teachers out there, because pen and paper, like, it can create a lot of time, but then when you see the technology through the lens of the world of individual who have disability, right, you will see it's important, not just an aid to education. I'm open for questions here, and I can answer any specific question to the startup, to assistive technology, what we've talked about. If anything I missed, or basically any feedback on the entire conversation which we just had. I've already given you a lot of time, everybody. The PPT got over within 30 minutes. It was supposed to go to 1.5 hours. So if you have any questions, that would help everybody in this session. And you might be able to start your own startup one day. You might not see the importance of assistive technology as of today, but once you go back and see how many around you are actually getting benefited by a simple text-based voice at your home through the feature of that mic in your home or around you, or the simple act of slope in an infrastructure when there is a wheelchair, how many actually benefit. Once you start observing all of this, right, it will make more sense to you why we're having so many sessions on assistive technology for the past 2 days, and there's one more day tomorrow as well. So if you're clear about it, that's good enough. But if you have any questions, use this opportunity today. Either if you want to start a startup into these kind of social impact, or if you are a student who's trying to create something or have a project around it.
Thank you, ma'am, for an insightful webinar on the role of assistive technology in education during the FDP. Thank you, ma'am.
Thank you.